welcome everybody to one more video of Gyan Gurukul. So today in this video we are going to talk about a law that is known as the Gauss Law. So as you can see here on the board, I have already stated the law. It states that the line integral of electric field intensity over a closed surface in vacuum is given by 1 by epsilon naught times the charge enclosed by the closed surface. So what do you actually mean by this statement? Mathematically speaking, the statement can be written down as line integral, a closed line integral of the electric field intensity over a closed surface is given by 1 by epsilon naught times the charge enclosed by. So this can be written as a mathematical formula. So if we integrate the total E dot ds over a surface, then it gives us the total flux, the total electric flux of that surface. So that is represented by phi e. So phi e can be given as 1 by epsilon naught times the q enclosed. So if I draw a closed surface and if I say that surface encloses a charge of suppose 2q, then the total flux for this particular surface would be directly given by 1 by epsilon naught into 2q. So that would be 2q by epsilon naught. Now if I draw one more surface concentric to the earlier surface having a bigger radius, and if I say that there is another charge of suppose minus 6q over here, then if I name the inner surface as A and the outer surface as B, now if I ask to write down the flux for both of the surfaces individually, then the flux for A and the flux for B can be written down as, since A covers a charge of 2 coulomb only, the minus 6 coulomb lie outside the surface, hence for A the total charge enclosed would be 2 coulomb. So the total flux would be given by 2q by epsilon naught. But for B, as you can see, the surface B encloses both of the charges, that is 2 coulomb as well as minus 6 coulomb. Hence the total flux for the surface B would be given by adding of both the charges. Since charges are additive, we can directly add them, so it will turn out to be minus 4 coulomb. So the total flux will be given by minus 4q by epsilon naught. So this is what is actually meant by Gauss law. Next, we need to know how to prove this particular law or this particular theorem. So in order to prove the Gauss law, let us consider a sphere having radius r and a charge q at the center. Okay, so we are taking a sphere of radius r with a charge q that is placed at the center of the sphere. Now if I ask to write down the flux for this particular surface or for this particular sphere, how can I do so? Now in order to do that, let me first consider a small surface over here. Let that surface have an area of ds. Now again, the particular surface will also have an area vector. Now what would be the direction of the area vector? The direction of the area vector is always radially outward from the center. So since we are considering the surface here, so if I draw a center line, so the area vector would be somewhere here. So this is the direction of the area vector. Now again, for this particular charge, if I ask you to give me the direction for the electric field, now that direction would again be radially outward. Since it's a positive charge, the direction of the field would again be radially outward. So for this charge, if I need to write down the direction or draw the direction over this area, then the direction of the electric field would also be in the same direction, that is along the area vector. So if I have to write down the expression of electric flux for that particular surface, how am I going to do so? So that can be done as E dot ds, right? So E dot ds is going to give me the smaller phi for this particular smaller surface. So let me take it as d phi. So I can write d phi equals to E dot ds. In order to get the total flux, I need to integrate it both on both the surfaces or on both the sides. So on this side, I'm going to get the total flux for that particular sphere or for that particular closed surface, and here I'm going to substitute the expression for electric field, and then I'm going to integrate the result of that expression along with the area. Okay, along with the surface area. So what will be the expression for electric field? First of all, electric field for this particular charge at a distance r would be given by q by 4 pi epsilon naught r squared, right? So the integration would look like as q by 4 pi epsilon naught r squared ds. So I can take the constants out. So q by 4 pi epsilon naught r squared would come out. This would only be integration over the surface ds. Now we all know the total surface area for a sphere. The total surface area for a sphere is given by 4 pi r squared. So the integration of ds will give me the total surface area, which will turn out to be 4 pi r squared. Hence this equation would look like as phi equals to q by 4 pi epsilon naught r squared into 4 pi r squared. So if you cancel out the 4 pi r squared part, will be left out with phi equals to q by epsilon naught, which is actually the proof of the Gauss law. So that is all about the proof that you need to understand in order to get the Gauss law according to the expression of phi equals to q by epsilon naught.